So Shrikant, it's great you can join us. Thank you so much for joining today's ARM Tech Talk, and let's take it away.
Sure. Yeah. Thanks, Tobias. Thanks for having me here. I'm very excited to be part of this. So just a brief introduction about me. As you mentioned, I'm a senior product manager, part of the secured and connected edge business unit at NXP Semiconductors. So we are very excited for our next generation i.MX 9 application processor series. And this i.MX 93, which is going to be the focus of today's presentation, is the first family application processor family in the 9 series. So I'd like to start with giving the outline of this presentation. So as I mentioned, like now I would start with the application process that we have from NXP and also go into detail about this i.MX 93, which is going to be the focus of today's presentation. I would give some architectural details as well as detailed presentation on the feature set, as well as what the target applications are for this processor. And then we'll focus into the machine vision capability of the i.MX 93 and talk about the hardware and software enablement that we have, and finish the presentation with the machine learning demo that we have. So from NXP Semiconductors, we have had application process or like our edge device compute processors for a while now. So we cover from all the way from a low end like an MCU microcontroller to a high end processor, could have like multiple processing units. So basically we cover the entire area here. And in between, we do have something called RT, which is a crossover between the MCU and the MPU, which is so today's presentation. i.MX 93 is a microprocessing unit, so it's application processor, and I'm going to talk about how we evolved over the period from application processor point of view at NXP. So i.MX is our brand name. We have had application processor series for the past like 15-20 years. Our the currently i.MX 6 is the most widely used application processor in the market. It has 12 different product families, and it offers a lot of software compatibilities and pin-to-pin compatibilities between families. So it's basically easy to move from one family to other. So having this mindset, this is very, very, very useful, and this is what our customers like about our i.MX processor families. So we've used this feedback and we've kept this in mind when we are actually creating this next generation i.MX 9. So today i.MX 93, we are close to being into production like within the next 4 to 5 months. We have already launched the pre-production samples and evaluation kits. It's in the market, available in the market today. And the other product families that we have on the i.MX 9 are the i.MX 95, which is our high-end product, which we have announced at the CES earlier this year, and also a low-end product i.MX 91 that we recently announced earlier this week. So before I go into the application process, I want to quickly state what are the differentiating factors that we bring apart from the application processor features or enablement. NXP offers we have supply commitment in terms of how long we provide our products. We call it NXP's product longevity program. So most of our application processors are either part of our 10-year or 15-year longevity program. So i.MX 93 is part of the 15-year longevity program. So as I mentioned, we will be in production by close to end of this year. So we guarantee supply in the market for the i.MX 93 at least for next 15 years, which means at least until 2039. So that is one part of it, because this is very critical for industrial or automotive customers, because typically they have longer cycles for production cycles, and they want to be able to get the processor samples going for 10 years or 12, 15 years from when they actually start prototyping. And the other thing that we do that our customers love is being able to qualify our processors based on how the use case or what the application is. So based on the different segments, the qualification levels are different. I've given the different qualifications level here. I don't want to go into details, but we provide different qualification tiers, levels for the different segments, which is another key factor for going with NXP when it comes to application processor. So quickly jumping into i.MX 93, what are the differentiated features that we have on this SoC? So when we talk about application processors, like the most critical things that come to mind is are the security. First thing is security, because as we increase amount of processing on the device, we also want to make sure it's secure enough that there's hacking and untoward activities does not compromise the processor or the entire system on which the processor is sitting in terms of the network and everything. So we take that very seriously. So we have I have like few slides covering these, go into details, but just quickly talking about it, we have EDGELOCK secure enclave to provide the high security that is required for the application processor. The second thing that comes to mind for customers is higher performance with lower power. So that's typically what our customers need. So in order to tackle low power, we have energy flex architecture. So that's the architecture that we are using for the application processor to enable customers to go and achieve low power or high performance depending on the needs. And then the third thing is being able to scale their processing power performance from say one to another without spending much time. So what this means is on this i.MX 93 we have a single Cortex-A55 core option or a dual core option to run the application. So depending on the needs of customer, it can easily move from a single core to dual core SoC because they are pin-to-pin and software compatible. So it's just a drop and replace. And then apart from that, apart from the Cortex-A55, we also provide an on-chip MCU in the form of Cortex-M33. This is very critical for achieving low power modes, as well as to be able to cater to say industrial or automotive use case that involves a lot of real-time processing. And then the other exciting thing that we have added to this i.MX 93 is the NPU, a dedicated neural processing unit, and we've integrated the Arm Ethos-U65, which is a very high efficiency neural processing unit to accelerate the machine learning computations. And apart from all these processing units and features, the other main thing that we are also incorporating is the amount of interfaces that we have on this chip. Because without the specific interfaces, customers are not going to being used to use the chip, because interface is the way you communicate in and out of the chip. So basically we provide very rich set of interfaces, and we make sure we cover the interfaces that are required for each and every segment that we want to go into. So quickly going into the different processing units here, as I mentioned, we are using a Cortex-A55. So in our previous generation, we had a Cortex-A53, and we've upgraded to a Cortex-A55 in this current generation. And as you can see, these are published results from ARM comparing the two Cortex-A cores. You can clearly see here that the Cortex-A55 offers better performance, both integer and floating point, but it also offers better power efficiency. And these are some of the numbers that actually we actually see these from measured silicon results on this product when we compare against our previous generation. So we see that we are able to offer better performance, but even coming at a lower power when compared against A53. So going to the security topic, we have something called the EDGELOCK secure enclave. Again, this is a patented design from NXP, and you can actually go to nxp.com and search for EDGELOCK, and you're going to get a lot of materials. But just to quickly cover this, the EDGELOCK secure enclave provides different types of security features, like basic types such as say a secured boot or secured debug, but all the way up to say establishing a silicon root of trust, also for the different cryptographic key management, and also provide trust provisioning and runtime attestation. So all of this is enabled using this EDGELOCK secure enclave. And also the other thing that we provide is we try to certify our secure EDGELOCK security block, so that it enables customers to go and easily certify the SoC or their application at the system level. So from the power consumption point of view, as I mentioned, this energy flex architecture that we use at NXP is enables us to go after high performance or low power, whatever the customer needs. So the way we do that is we divide our application processor, in this case the i.MX 93, into multiple domains, and each domain has its own clocks and has its own supply voltage. So for example, here the Cortex-A55 and the cache and everything that goes around it is part of the application domain. The Cortex-M33 and its TCM and other interfaces that are coupled to it is part of the real-time domain. And then the NPU, which is the Ethos-U65 from Arm, and its SRAM and the devices that go around it, is part of the flex domain. And we have other flex domains like for graphical or for camera interface, those kind of things. So everything is part of its own flex domain. And each of this domain is individually I have individual clocks that are separate from the other domain, as well as the supply voltage. So we provide the knobs here because customers can go and say clock gate a particular domain if it's not used, or they can power gate it, or even operate it at a lower frequency or a lower supply voltage, depending on the needs. So basically, it provides knobs to the customers to trade off performance versus power. So for customers that need, say, low power, for example, the industrial customers, they typically want to have low run power. So they can optimize the run cases, switch the A55 core frequency, or change the M33 core frequency, or do those optimization to get the required power numbers. The other important thing, as I mentioned, is apart from the A55, the M33 core is very critical to enable customers to go after low power, because as you can know, the A55 provides high performance, but it also comes with additional power that is required to run the A55 to achieve the high performance. On the other hand, the M33 is much more optimized for power, but obviously gives you lower performance. So use cases that involve low power, or even not that, right? A use case can have, say, 90% of the time the customer do not need the performance of A55. You can basically, the customer can switch off the A55 completely because of our energy flex architecture, and then move their application to the M33, where the M33 is now running the application at much more optimized power, even close to 1/10 of the power that the A55 is consuming. And then once, there is a wake up event, or once there is an event that needs the A55 to be on, so you basically now turn on the A55 and then move the application back to A55, and then you run it. So basically, having both M33 and A55, we are able to provide performance as well as power optimization. On the other hand, apart from the low power, the M33 is also used to achieve real-time, applications or use cases that are critical for automotive or industrial segments. So this table compares the different feature sets that we have on the i.MX 93 family. So basically, we have three different packages for this SoC. We have a 11x11 0.5 millimeter pitch package and a 14x14 0.65 millimeter pitch package. So both of these packages are exactly same, apart from the pitch size. And then the third package is a 9x9 0.5 millimeter pitch package, which is a low cost but a smaller package. So being it a smaller package, we have less number of interfaces, less number of features, and in some cases there are some lower performance as well. So I quickly go through the different performance or feature sets for these packages so that it's easy for someone to select. So from the main CPU perspective, the Cortex-A55 single and dual options are available across all the packages, and we are able to achieve 1.7 gigahertz max frequency across all the packages. And then from the MCU perspective, the M33 running at 250 megahertz. Again, that's going to be constant across all the packages. From the DDR perspective, the i.MX 93 family, we support LPDDR4 and LPDDR4X 16-bit version. And we're able to hit 3.7 gigatransfer per second in the bigger packages, which is the 11 by 11 and 14 by 14, while we are at 3.2 gigatransfer per second for the smaller package. So from the other feature sets, such as the graphical processing, the security, the Ethos-U65, it's all like, it's implemented on both the packages. When it comes to the interface, you're going to see that the 9x9 has less number of interfaces. So on the 11 by 11 and 14 by 14 for the camera, we have a MIPI CSI, which is a critical interface to achieve vision or solutions related to camera. So we have MIPI CSI 2-lane supported on the bigger packages and parallel camera interface. While on the smaller package, we support only the parallel camera interface. Similarly, from the display front, we have a MIPI DSI and LVDS being supported on the bigger package, while the parallel display is the only interface supported on the smaller package. And then the other main differences here are the USB. We have 2 instances of USB in the bigger package and 2 instances of gigabit Ethernet in the bigger package, while both of them are reduced to a single case for the smaller package. The other main thing is all of these packages. So mainly we are focusing the 14 by 14.65. We are positioning that package for the automotive segment. So and then the 11 by 11 and 9 by 9 is going to be used for the consumer IoT or the industrial IoT segment. So we provide consumer qualification, industrial qualification on the 9 by 9 and 11 by 11, and the automotive qualification on the 14 by 14. So in terms of the machine learning and vision engines, there are 3 different processing units that we have on this application processor that can be used. I think you would have already guessed by now. The main, when it comes to running ML applications, we have the dedicated NPU in form of the Arm Ethos-U65. So, and the maximum frequency at which it runs is 1 gigahertz. On the general cores, we can run the machine learning on the A55 core. And again, we are able to achieve 1.7 gigahertz there. And for any low power, like say a voice ML application, you can still use the M33, and we are able to run at 250 megahertz there. So what are the different target applications? And this is just specific to ML, and I'm not considering anything apart from ML here, because there are multiple other applications numerous other applications that basically i.MX 93 can cater to. But this slide shows just the ML front. So vision is very critical, in terms of what are the things that are needed for vision application is we need a camera interface, say a MIPI CSI, which is typically preferred, because it provides low noise and better performance compared to a USB. But then you can still use a USB or a Ethernet also for vision applications. So basically we have all those interfaces. And apart from that, we have the processing capabilities in terms of the A55 and the M33, but in particular, we are having this Arm Ethos-U65 enables us to go after those entry-level vision applications that need machine learning acceleration. And some of these example applications are given here. And again, this is across multiple segment. It's not just a single segment. For example, on the industrial automation front, there is industrial machine vision, for example, where a camera is sitting and watching a conveyor belt where the finished products are moving along, and the camera is able to basically provide the image to the processor, where the processor now, based on the camera image, can find out if the finished goods have defect, and then based on that, it can take an action. So that could be an example industrial machine vision, which is a perfect fit for i.MX 93. And apart from that, scanning and printing that's used in industrial segment is again good use case. On the other side, on the automotive side, we have this driver monitoring system or object monitoring system where you have a single camera, like focusing a driver, for example, making sure he's attentive, making sure he or she, like, doesn't doze off during driving, and being able to provide feedback to the driver on any of his actions. So basically, that's something that is critical, and that we feel like, i.MX 93 is very suited for those kind of applications. And then the typical consumer IoT applications, such as say a smart doorbell, smart lock, where it basically recognizes a face, and then based on that, it basically opens the lock, or or basically does some action based on that. So those are also applications that are fairly well suited for i.MX 93. So jumping into the ML capabilities with this Arm Ethos-U65, I wanted to start with providing details on what the Arm Ethos-U65 brings to the table and how it does it. So this is a very high level block diagram of the different cores and how they are connected. I have a different figure coming up in the next slide, but in terms of the overall, why we selected the Arm Ethos-U65 is because of its very high efficiency in terms of not just the performance and power, but also the area. It consumes very less area, physical area. So it fits very well into the i.MX 93 application processor positioning, because this is an entry-level application processor. So we want it to be as compact as possible, because it's going to serve a very cost-sensitive market. So this Arm Ethos-U65 sits perfectly well with that objective. Apart from that, it also has very small memory footprint. And then obviously, the NPU, Ethos-U65 offers hardware acceleration when we run machine learning models. And then it also does compression, model compression on the fly, decompression of the weights. And then from NXP, we have this EIQ ML machine learning software development environment, where basically we provide tools and enablement for the customers to easily start working and developing models that are custom that are needed in for the i.MX 93. So basically, the takeaway for this slide is the Ethos-U65. If you're looking for a high efficiency, low cost, low area version of a NPU, this is the one of the best available IP in the market today. So going into the hardware architecture, as I mentioned, there are three processing units: the M33, the A55, and the Ethos-U65. So in terms of the architecture, the Ethos-U65 is connected to the M33 directly, and there is no direct connection to the Cortex-A55. So basically, if the Cortex-A55 needs to access the M33, then it has to use the messaging unit and then talk to the M33, and through that, it has to access the Ethos-U65. And then the Ethos-U65 also has 384 KB of RAM that is specifically assigned for the NPU, to the NPU, which is different from a TCM of M33 or a system SRAM for the entire SoC. So this is a dedicated SRAM assigned to the Ethos-U65. And then in terms of the other memory units, in terms of DDR, basically there is direct access from the system bus for the Cortex-A55 or the Cortex-M33, and then also for the Ethos-U65. And then basically, the DDR obviously is used to store the model weights, bias, and other things needed during the ML computation. From the software side, we have two interpreter engines that can be used. So first of all, it starts with the compiled model, and I have a slide next and to show you what that means, where to do or how to get this compiled model. But once you have a compiled model, you can either use an inference API interpreter engine or a TF Lite interpreter engine. And the the difference is like, when we use the inference API engine, you're going to have all the operations being controlled by the A55, and whatever is optimized and can be run on NPU Ethos-U65 will be run on the Ethos-U65 block. While using the TF Lite interpreter, it's basically the other combination where you have the M33 and the Ethos-U65 as the oh, I think I switched that. Sorry for that. So it should be the other way. The TF Lite interpreter basically provides the path to running the ML applications on the A55 or the Ethos U65 core, while the inference API provides the path to run the models on the Cortex-M33 or the Ethos U65 NPU core. So basically, when the compiled model, the inference, this API looks and it actually finds what are the operators that can be run or that is suited for the NPU, and those operators are run on the NPU, and anything that the API finds that cannot be run on the NPU will be run either on the M33 or the A55 based on which engine you're using. So in order to compile the model, ARM provides Arm Vela Compiler. So basically, it converts the quantized TF Lite model, and it basically exports it to a version that can be run on the U65. So again, if you don't use this Arm Vela Compiler, the model will run on the SoC, but it will run only on the A55. So you won't be utilizing the capabilities of the NPU. Only if by having a compiled model, you can basically utilize the Ethos U65 NPU in the machine learning use case. And then, as I mentioned, basically it converts the TF Lite operators to custom operators that the NPU can decipher. But then any operators that are not converted will basically run on either the A55 or the M33. And also the other important thing that the compiler does is it reduces the overall model size and also the memory footprint. So basically it provides very optimized runtime performance. And again, this is free to download, and we have a link here. So there are two ways to do this compilation, because this is the first step that we want to do, right? So there are two ways. One is from the command line. We have you can obviously use the commands that enables you to compile the model. But then from the GUI, we have this EIQ, as I mentioned. NXP has a EIQ machine learning software development environment. So through that EIQ portal as well, we have a GUI screen where you basically can directly select the i.MX93 and then provide the model name. And one good thing about this using the EIQ is all the settings and configurations are already done and for the i.MX93. While if you're using a command line, you would have to set the configurations and settings by yourself. So basically, this might involve a few additional steps. But if you use the EIQ, basically it's all pre-configured, so it should be seamless. You should be able to do it quicker. So once we have the SoC from NXP, we offer evaluation kits to evaluate the product, and we enable customers to run their application and measure performance or measure power. So this is the evaluation kit that we have for the i.MX93. So we have a base board that has a lot of these connectors, and then on top we have a compute module that has the i.MX93 SoC along with NXP PMIC, which is the power generation module. And then also the eMMC and then DDR. And the other important thing that we have in this EVK is you see these smaller IPs, those are power measurement IPs. So basically you would be able to measure power consumed on each of the power rail going into the i.MX93 SoC. So basically the customers can use this evaluation kit to measure power and performance and so on. And the other important thing is from the Wi-Fi perspective, we have the NXP IW612 Wi-Fi, and that is connected through the M.2 connector, which is on the backside of this EVK. And from the software perspective, the board supporting package, which we call as the BSP, software will include not just the i.MX93 application processor, but also will have the PMIC, the PCA 9451, as well as the IW612, which is the backside pre-configured. So customers do not have to individually go and develop drivers or integrate PMIC. It's already pre-done, and it enables customers to reduce the overall design cycle. So this is an important slide that I wanted to share with you. This shows what the importance of having a NPU, and in this case, the Ethos-U65. Basically, this shows for the different models that we have considered, what is the performance enhancement that we are seeing on running a model on a Ethos-U65 compared to the Cortex-A55, right? So for the different models, you can see it's at least 20x better. And sometimes it goes all the way up to even 45x better. And this is inferences per second. This is the performance metric that we are taking, and we are basically normalizing the performance of the Ethos-U65 to the A55. So this shows that having a dedicated NPU and in Ethos-U65 provides much better ML performance. Basically, this assists for vision applications, for ML applications. Having this Ethos-U65 provides you with better performance and being able to achieve. And the other thing that is not given here is we have some power measurement for both running the ML on a A55 and on the U65, and we are seeing actually not only this 20 to 45x performance increase, but we're also seeing at the same time we are able to actually consume less amount of power while doing the machine learning operations. So Ethos-U65 provides better performance as well as coming at a lower power. So that's very critical for a lot of our customers. So from the software enablement side, as I mentioned, NXP has a EIQ software development environment where we basically have enable customers to either bring a model if you already have ML models, or you can even start using the model selection, model training, and all those steps that are needed to create the models. And then again, once the model is created, you can use the EIQ portal to deploy the model and start running the inferencing on the i.MX93. So this slide shows how the inference engine options looks like, and what are the different i.MX processes that we have enabled using this EIQ portal. And as I'm showing here, the 93 is our latest application processor that is supported on this EIQ engine. So wanted to quickly show a demo on how a machine learning application. So this is a DMS, a driver monitoring system demo on the i.MX93. As you can see, this is our setup. This is the evaluation kit that I showed in the previous slide. A monitor and a camera, which is not shown. The camera actually sits on top of this display, and this person is actually looking into the camera. And then based on the actions of let's assume this is the driver, right? So based on the action of this driver, you're going to see the different. So as I mentioned, this is, let's assume he's a driver and he's trying to be distracted, he's not in the window, and basically the SoC is able to find that you're not able to find the driver. And then now he's going to show that he's going to be distracted looking at something else, and basically it starts reducing this, and showing that this is it's a danger to the driver as well as the automotive and everything. So like different things that are done here is like looking at whether the driver is distracted. So basically looking for face and what direction the face is facing. The second thing is looking at the eye and see if he's opening or closing the eye. So basically, if he's closing the eye, it means he's drowsy. Then looking at the mouth movement, like if he's like yawning. And then also the other thing is like if he's doing other activities while driving the car, could be like drinking a cup of tea or smoking. The other main thing these days, like, are you distracted using your phone while you're driving? So those are some of the typical things that are done unique, like during a driver monitoring system application. And all of this can be achieved using the i.MX 93 with the great performance coming in. And these are the different models that we're using to do the different applications. As I mentioned, the first thing that we do is detect the face. And then based on the face detection, we do the landmark. So basically find the eye, mouth, and then using the iris landmark result, you see whether the eye is open or closed. And then on the other side, we look for object detection. We look for whether there is a camera. You can include like a teacup or whatever object you want to do. And then based on that, all of this, based on the action of the driver, basically the SoC is able to find the deduce the action and then find out what the impact would be for when it comes to the driving application. So that's our demo. And so to summarize, as I mentioned, NXP just recently launched i.MX 93 application processor family. We are very, very excited for this product family. This is the first in the i.MX 9 series and many more to come. We're very excited because this basically i.MX 93 enables us to go after customers to develop very cost optimal solution, entry-level machine learning applications are key applications that can be developed on the i.MX 93. So we have the hardware capabilities to support it, as well as we have the NXP EAQ toolkit from the software perspective, enablement. And then also we have a lot of demos that we are developing. And any questions, please contact me or Ali, who's part of the panel here for anything related to i.MX 93 or anything related to ML capabilities at NXP. Thank you. And next, I would like to we have this ARM virtual hardware that we are partnering with ARM, obviously, to develop this virtual hardware capabilities, and we've already done that on the ATEM Plus, which is our last product. And this new product, i.MX 93, it's already ARM has already added support for virtual hardware, and it can be done on both the Cortex-A55 and the Ethos-U65 NPU. So ARM would be having a demo at our NXP Connects event happening next week in the Bay Area. So if please come by, swing by the demo booth if you have any questions regarding the virtual hardware or any enablement needs that you have from ARM. And also, we should have multiple demos on i.MX 93. Also showcasing a lot of these ML capabilities. So please swing by. If you're not already enrolled, please visit nxp.com, search for Connects events, and then please register, and hope to see you all there.
Thank you, Shrikant. That was awesome. Awesome presentation and fantastic tech talk. Thank you. And really, really excited about the Arm virtual hardware implementation as well. And actually, we've got Eric Sondy, Senior Manager of Arm Virtual Hardware, on the call. Eric, just before I get to questions, do you want to quickly, for 30 seconds or so, call out anything on Arm Virtual Hardware and our work with NXP on this? Anything further you'd like to add?
No, thank you. Well, thank you, Shrikant, for this excellent presentation overall. It's really fantastic to see the adoption of the Ethos-U in particular and what you've been able to do with it. The virtual hardware is, as Shrikant said, it's available for the i.MX 93. It's a fully functional cloud native device that you can access on avh.arm.com. And we're in a public beta. So anyone with an ARM account can access and start playing around and doing software development in the cloud with the i.MX 93 today. And then, as mentioned, looking forward to seeing anyone who wants to learn more next week at NXP Connects. We're very happy to share our software-defined camera demo at that time, and we can show how it runs on the i.MX 8M Plus with the AVH alongside hardware, and so how it's a very complementary usage with actual hardware. And then we can also show you porting some of the ML object detection in the software-defined camera use case on the i.MX 93 AVH for the very first time from our side. So I'm really looking forward to it. And thanks again, Srikanth.
Amazing. Thank you so much, Eric. That's really great. And yeah, definitely check out the NXP KNX events. The demo is awesome. So it'd be great if you can go and join and see that. So we're going to get some questions. Now we've got about 10 minutes for some questions. I've got a couple, but just to kick things off, and then we've got a ton coming in that I've seen Ali has very kindly answered quite a few. We should have plenty of time to get to the rest. So I guess the kind of question at the top of my mind, and I'm sure at the top of the audience's mind, right, is when's the i.MX 93 actually going to go into production for people to place orders, and how much is it going to cost?
Sure. Yeah. So we have launched the pre-production samples and evaluation kit. So today you would be able to go to nxp.com i.MX 93 webpage, and you would be able to order evaluation kit and samples from there. But these are pre-production only. So we are planning to go into production by Q4 of this year. So by say mid of end of October, early November, you should be able to get production samples and production EVKs from NXP. And
awesome.
Yeah, in terms of the overall pricing, the samples, the SoC is priced anywhere between say $5 to $8, depending on the volume and depending on the configuration and qualification you're looking for. From the evaluation kit point of view, I think it's about $600, but it has you're able to implement all kinds of applications. It's very general purpose. So it's $600 and available today on our website as well as our distributors.
Awesome. Thank you. So not long to wait. So thank you for that. And how much, I'm really keen to understand from your side, what's the kind of interest been with from the customers on the kind of AI ML capabilities of this, the i.MX 93 with the U65? Could you talk a bit about that?
Definitely, Eric. So, sorry, Tobias.
Right.
We're very excited, right? When we actually started designing this product, we had we knew that the customers are looking to develop ML applications and AI. You see that a lot of people are actually customers are moving towards the AI side of it, but we still had some questions going into it because this is still an entry level application processor. We didn't have any such product before that had ML capability, dedicated ML capability. But now, when I'm talking to customers as part of my launch and everything, I feel the excitement from customers. They really want to see application process with dedicated NPU, with being able to run high performance ML applications, and even from entry level perspective, so it definitely validates our initial plan to put the Ethos-U65. And now when we look at the results and we present the results, the one that I showed, and we have a few more, they are very, very, very excited to see this. You can basically look at how the Ethos-U65 provides, say, 20x or 40x performance when you compare against a regular general purpose ARM core, right? Like a A55 or A53. A53 will be even slower compared to the Ethos-U65. So definitely having these results, it excites our customer even more. So we have a lot of interest coming from customers, and I know for a fact that they are looking for application process that has this NPU capability. So that's Absolutely. A very, very big plus. Yeah.
That is great to hear. Thank you for that. And that's a really great answer. And we're thrilled to hear it as well. So yeah, super excited to get this into people's hands and see what they can do with it. Right. And see what they say. So thank you for that. So in terms of the questions, we've got a ton coming in. So if you want to make sure that your question, or if you see a question that you like the look of and want that to be asked first, just hit the little thumbs up button in the Q&A box. That means I get to those first at the top of the list. So we're going to go to the top of the list with George has asked a question around the documentation, which speaks of the i.MX 9352 variant of the i.MX 93 chip. And the slide mentions a number of variants. What you just wanted to check which variant of the i.MX 93 is on the evaluation or development board.
Yeah, so we have the full-featured 9352. So that includes that's the 11x11 package with the NPU enabled along with two A55 cores. So that's the 9352. And it's industrial qualified. So 9352C is the SoC variant that we have on the evaluation kit. And for any information on the different variants available, please go to our website, again, nxp.com, i.MX 93, and we have our data sheet, we have reference manual, we have all kinds of collaterals there. So please have a look at those, and you would be able to see the different options that you have for the different packages, and what are the different part numbers we have for this chip.
Fantastic. Thank you for that. That's really great to know. And there's a couple of questions around the kind of real-time power and energy measurements. So, in fact, they're both from Krishna, I believe I'm pronouncing that correctly. So does the hardware development kit allow us to make real-time power or energy measurements? And then there's a follow-up question around the power energy difference between using A55 versus M33 for particular use cases.
Yes.
So I don't know if you wanted to comment on both of those, as they're kind of related.
Sure. Yeah. Yes, Toby. So yeah, Krishna, definitely, the EVK has power measurement capability, as you mentioned. It has power measurement ICs on the chip, and you would be able to measure the power on each of the power rails going into the i.MX 93 from the PMIC chip. So first of all, that's the first answer. The second one is when you run the A55, as I mentioned, it provides higher, it gives you high performance, but obviously it comes at higher power. While M33 offers lower performance coming at lower power. So depending on the customer use case, you want to either have a A55 enabled or the M33 enabled. So just to give a rough estimate, obviously this depends on the frequency that you're running at. So we are running at 1.7 gigahertz on A55 and 250 megahertz on M33. For a typical silicon room temperature, we see about anywhere between 6 to 10x difference in the power when you run a similar application on each of these different cores. So that's how much of power savings you can go from, say, A55 to M33, right? So yeah, and again, you can use our evaluation kit to measure this power, and we also have software enablement on the evaluation kit to basically plot power or do different kinds of it's a UI based software. So basically you would be able to do all kinds of stuff with the enablement that we provide for the power measurement.
Awesome. Thank you for that. And there's actually a follow-up question. I know you briefly, in fact, you did touch on this in the presentation, I believe, and you just touched on the software side of it as well. But just wonder if you could just talk through a bit more around the software that's provided by NXP for this SoC, one of the questions that's just come in.
Sure. So, I mean, from software perspective, we have the Linux kernel supported. So we have every quarter we have our Linux BSP released from NXP. So this i.MX 93 has been included from the Q1 end of Q1 Linux release. So that's for the A55 side. On the M33 side, we also provide the RTOS also supported. And then apart from these two, the Linux and the RTOS, free RTOS, we also support, we're working very closely with partners to enable VxWorks, QNX, Green Hills. So these are some of the OSs that are typically used in, say, industrial or automotive setting. So all of these are we're working with them. It's not released yet, but it will be released by close to end of this year.
Fantastic, thank you. And can you select between running a single core A55, dual core A55 on any of the packages? So the i.MX 93 1, 33, or 30?
Yeah, definitely. So it can be done through the software, and yeah, all of these different ones, the 935 as a single dual core option, 931 and 933 and 930, all of them have single dual core option. And from the BSP, the software BSP, you would be able to select the cores that you want to activate.
Awesome, thank you. And how do you change the frequency of the A55, M33, or U65? Can you do that in the software? Is there an API that sets frequently?
Yeah, correct. Through the software, that's correct.
Amazing, thank you. And then the last two questions: are there the M33 pins available hardware-wise?
I don't know what that means, but M33 is a processor that is sitting inside the SoC. There are interfaces, which means there are pins or pads interfaces connected directly to the M33 to do real-time applications. If that is the question, then yes, we do offer them externally, but the M33 by itself does not have any pins or anything. It's just a processing unit sitting inside.
Thank you. No, thank you for clearing that up. And finally, is a Yocto image, including the meta layers, available?
Yes, it is available. It is available today.
Amazing. Thank you so much. Well, those are awesome questions. I love it when the audience is really engaged. So clearly this is a really interesting topic, and I certainly agree. It's been a really great tech talk. Lots of fantastic content, and the slides will be available afterwards. The recording will be live on YouTube immediately afterwards as well. So do check that out if you missed any part of the presentation. So I think we'll wrap up now, and really appreciate everyone's great questions. Before we do, Shrikant, do you have any final words for our audience
Sure. Before
we wrap up today?
Yeah, definitely. Thank you, Tobias. Thanks to Arm for having us here. I love the webinar. I've viewed a few of my few of the Arm Tech Talks, and I'm hopefully this is as good as what I've viewed before. But definitely, thank you for having me here. And I'd like to thank all the audience here as well to patiently go through this presentation, as well as please visit us at Connect's event happening in the Bay Area. Again, that's next week. But also apart from that, we have NXP Tech Days, Technology Days. From I think July till September, October in different parts of the US and even actually around the world. So if you go to nxp.com and search for Tech Days, you would be able to find the different events, and please try to register and come. And we have a lot of these kinds of technology related talks and presentations in those events, and you get first-hand information directly coming from our experts at these events. So hopefully we meet you there in those events. And again, thanks to everyone. Thanks for having me here.
No, thank you for an awesome presentation, great content, and we really appreciate you putting this together. Audience, I hope you've really enjoyed today's tech talk. I certainly have. We've learned a lot about how you can use the i.MX 93 today in your ML applications and take advantage of the evaluation kit today when it's coming in as a SoC, as a future in the year, and the opportunities with Arm's Ethos-U65 accelerator. So we're really thrilled to be working with NXP on this and have them in today's tech talk. And of course, you can also try out the Arm virtual hardware instance of this as well. So please do check that out. Head to arm.com/virtual-hardware, and you'll be able to find out all the details about that and get access to try that out. So we'd love to hear your feedback on that as well. So Shrikant, Ali, Eric, thank you so much for today's presentation. Really appreciate all the content, great answers to the questions. Audience, thanks for some awesome questions too. And I'm really excited to see you hopefully at next week's Arm Tech Talk. Once again, for all the latest trends, technologies, and best practices from Arm and our ecosystem. And this time on June the 13th, same time, 8 a.m. Pacific, 4 p.m. BST, we're going to hear from Core AVI about how you can supercharge functional safety in the automotive space. So I'm really excited for that one. So make sure you register, head to arm.com/tech talks to do so. I look forward to seeing you there, or if not there, at a future Arm Tech Talk for all the latest and greatest from Arm and our partners. Shrikant, Ali, Eric, thanks so much again. Audience, we'll see you again next week.